Hello everyone, my name is TV Kumar and I'm from Sri Venkateshwar College of Engineering, pursuing my BE third year in Civil Engineering. Today I'll be giving a presentation on permeability and effective stresses. Permeability and effective stress are crucial concepts in geotechnical engineering. Permeability refers to the ability of soil to transmit fluids and is influenced by various factors such as soil structures, porosity, mineral composition. Effective stress, on the other hand, is an integral stress that affects the mechanical behavior of soil masses. This understanding is fundamental in analyzing the behavior of soil under different loading conditions, such as during the construction of buildings, highways, and dams. So let's learn the definition of permeability and what are the factors affecting permeability. So let's learn the definition first. Permeability. Permeability is the measure of soil's ability to transmit water or other fluids. It is influenced by factors such as the size and shape of soil particles, the degree of compaction, and even the presence of natural features of patches. So, what are the factors affecting permeability? Several factors affect permeability, including the type and size distribution of particles, the degree of saturation, and the hydraulic gradient. Understanding these factors is essential in predicting fluid flow through different soil types and formations. So what is Darcy's law and its applications? Darcy's law. Darcy's experiment resulted in the formulation of mathematical law that describes fluid motion in porous media. Darcy's law states that the rate of flow through porous medium is proportional to the potential energy gradient within that fluid. The constant of proportionality is the Darcy's permeability of soil. Darcy's law is a fundamental equation used to describe the flow of fluids through porous media. It relates to the fluid flow rate to the hydraulic gradient and the properties of the porous medium. What are the assumptions of Darcy's law? Darcy's law assumes that the flow is laminar, the flow is incompressible, and the liquid medium is isotropic, and the hydraulic conductivity is a constant. In this slide, we'll be looking into permeability of stratified soils and seepage velocity. So let's first learn about stratified soils. Stratified soils consist of a distinct layer with varying permeability. Understanding how flow differ through these layers is essential in geotechnical and hydrological studies. A soil mass consists of a small solid particles known as soil grains. When these grains arrange themselves within the soil mass, they create a void space. The property of soil that allows water or any liquid to flow through these voids is called permeability. Essentially, permeability measures how easily water can flow through soil. Seepage velocity. Seepage velocity refers to the speed at which water moves through the soil or rock due to hydraulic gradients. It plays a critical role in managing seepage-related concerns in engineering projects. Imagine a scenario where there is a difference in water level on either side of the structures, like a concrete dam or a sheet pile. Seepage occurs when water flows through the soil beneath the structures. In these cases, estimating the quantity of seepage becomes crucial and permeability plays a key role in it. In this slide, we are going to learn about superficial velocity and coefficient of percolation. Superficial velocity. The superficial velocity is the apparent velocity of a fluid flowing through the porous medium per unit cross-section area. It is an essential parameter in the design and analysis of fluid transport systems. Coefficient of percolation. The coefficient of percolation describes the characteristics of the flow of water through the soil mass. It influences the movement of water and other fluids within the soil, impacting the stability of engineering structures. What is the definition of effective stress and neutral stress? Effective stress. Effective stress is the intracellular stress transmitted between soil particles and is a critical factor in determining the strength and deformation behavior of soil mass under different loading. Neutral stress. Neutral stress is a stress state at which the pore water pressure is zero and it does not contribute to the total stress on the soil mass. Understanding neutral stress is vital in analyzing the stability of soil structures. So let us understand what is a quicksand phenomenon. So let's see how it forms. Formation of quicksand. Quicksand conditions occurs when there is a seepage pressure. This acts in the upward direction while overcoming the downward direction pressure. This is due to the submerged weight of soil and here the sand grains are forced out apart. This results in the formation of quicksand which cannot support a load on this sand. In geotechnical engineering, understanding and mitigating the risk associated with quicksand is crucial for projects involving foundations, excavations, and transportation infrastructures in areas with sandy or silty soils. Techniques such as soil stabilization, groundwater control, and proper foundation design can help prevent or minimize the occurrence of quicksand-related incidents. What are the characteristics of quicksand? Quicksand is characterized by its ability to engulf objects and individuals rapidly due to the decrease in effective stress, resulting in loss of shear strength and increase in pore water pressure. What is the relationship between permeability and effective stress? Impact of effective stress on permeability. The effective stress exerted on soil significantly influences its permeability, affecting the flow of fluids through the interconnected pore spaces. Behavior of permeability under various stresses. Understanding how permeability changes under different stress conditions is crucial in predicting final fluid behavior in geotechnical and hydrological applications. What is the importance of understanding permeability and effective stress in geotechnical engineering? Engineering, design, and construction. The knowledge of permeability and effective stress guides to design and construction of civil engineering structures, ensure their stability and durability under varying conditions. Geotechnical engineers rely on permeability testing to make informed decisions about foundation design. Understanding how water moves through the soil helps ensure stable and durable structures. What are the impacts of environment impact assessment? Understanding these factors is vital in assessing the environmental impact of construction activities on underground resource and soil stability. Effective groundwater management relies on knowledge of soil permeability. It affects the water movement, recharge rates, and containment risk. Permeability influences the fate of pollutants and containments in the soil. Properly managing permeability helps safeguarding the environment. Conclusion. Comprehensive understanding. A comprehensive understanding of permeability and effective stresses is indispensable in the field of geotechnical engineering, and it plays a pivotal role in enhancing the safety and sustainability of construction projects. In conclusion, understanding permeability and effective stress is essential in geotechnical engineering for evaluating the behavior of soils and designing effective infrastructure projects. Permeability refers to the ability of soil to transmit fluid such as water or air through its pore spaces, and it plays a critical role in groundwater flow, drainage, and seepage analysis. Research advancement. Ongoing research is in these areas continue to broaden our knowledge and improve the application of geotechnical principles in real life. Thank you everyone for watching this video. I hope you have a good day.